In this video, we're going to discuss the 5-number summary. The 5-number summary consists of the quartiles along with the minimum and maximum values. So you have the minimum value, the first quartile, the second quartile, the third quartile, and the maximum value. This gives you your 5 numbers. So let's look at an example. We're looking at chips per cookie. Students wanted to examine chocolate chip cookies. Therefore, they randomly selected 21 Keebler's Chips Deluxe chocolate chip cookies. They counted the number of chips in the cookies, and we want to construct a 5-number summary. So when we're doing this, the first thing that we want to do is we want to find our quartiles. In order to find our quartiles, we want to find first the median. And so when I'm finding the median, I'm going to come through here and find the very middle value and see what my middle value is. And since I had 21, my middle value is exactly the middle point, which is 25. So that is my Q2, my median. Okay? And then I'm going to erase my marks over these other numbers because I'm going to use those to find my Q1 and my Q3. Because remember that Q1, a couple of different ways I can find it, is the median of the lower half. And so I'm going to come down through here and find the median of my lower half. Well, it's the middle between these two. So Q1 is going to be 22 plus 23 divided by 2. So Q1 is equal to 22.5. I'm going to do the same thing with the upper half. I'm going to find the median of my upper half. And that's going to give me, marked out one too many, that's going to give me these two that I'm going to take the mean of. So that's 28 plus 28 divided by 2. So Q3 is 28. So I now have my first quartile, my second quartile, and my third quartile. The other two numbers of my 5-number summary are my minimum and my maximum. So for my 5-number summary, I have my minimum, which is 20, my Q1, which is 22.5, my Q2 or my median, which is 25, my Q3, which is 28, and my maximum, which is 33. Finding the 5-number summary is going to be extremely helpful whenever looking at other items. But this is how we find our 5-number summary. We can also look at outliers. Outliers are extremely important. These are the values that are considerably larger or considerably smaller than most values in the data set. Now, some outliers are a result of error, such as we may have misplaced the decimal point, wrote a number down incorrectly, maybe transposed the numbers. Some outliers are actually correct. They're correct data. We just don't know why they're so far off base or something. The important thing to know about outliers is we do not delete outliers unless we know absolute certain that it is an error. One way to know that it's an error is in the month of December, let's say in New York, we may have temperatures, and our temperatures are a 10, 12 degrees, 15, 10. This is temperatures in a week. And then we have a temperature that's 100. Okay? And this is in December in New York. Well, I know for certain that the temperature for 100 in New York in December is going to be a misplaced decimal. And so I am going to scratch that one out and delete it. Now, if it was, say, in September or August, I wouldn't know for sure. Okay? Different things of that nature. And so there are certain ones that we can, others that we don't know for sure. And so you have to be very careful about these outliers. Now, in order to find outliers, we must first locate what we call the interquartile range, IQR for short. The IQR consists of the third quartile, Q3, minus the first quartile, Q1. So we're going to subtract the Q3 minus Q1. We use this inside other formulas to find outliers. And what we do is we use this interquartile range method to find outliers. So to find our outliers, we compute our Q1 and Q3, and then we compute our IQR. We subtract those two numbers. Then we find what we call our outlier boundaries, a lower and an upper boundary, using this formula. Q1, which is our first quartile, minus 1.5 times our IQR. That will be our lower outlier boundary. And anything less than this lower boundary will be considered an outlier. To find our upper outlier boundary, we take Q3 plus 1.5 times IQR. Anything greater than this boundary will be considered an outlier. Now let's look and see what this actually means and how we would actually calculate it. So we want to look at the hemoglobin in cats. The following data represents the hemoglobin for 20 randomly selected cats. Use the IQR method to determine which values, if any, are outliers. And so we have 20 hemoglobin values here, and we want to see if there are any outliers. So the first thing that we do, of course, since we're finding the Q1, Q2, Q3, is to arrange them in order. And so I'm going to go through there and arrange them in order. Since you have a larger set of data here, sometimes it is easier to use technology to help you arrange this in order to make sure that you have all the values and in the correct order. Okay? Sometimes we do not have that capability depending upon where we are, but most of the time we have technology at our fingertips. And I'm going to have to go down here to a second row because I ran out of room. Whoops. And I scrolled down for some reason. Now let's see here. 10.7, 11. And I've got a few more here. 13 and 13.4. Okay, so here are all my numbers. And I want to first find my Q1. Or I'm sorry, Q2 is the first thing. And so there are 20 values. And so halfway through 20 is 10. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be in the middle here. So Q2 is going to be equal to 9.9 plus 10 divided by 2. So Q2 is going to be 9.95. Now, my Q1, since Q2 is right here, Q1 is going to be the median of all of this. There's 10 of them, so that's halfway. So I'm going to look halfway, and that's going to be the median of these two. So Q1 is equal to 8.9 plus 9.4 divided by 2. So Q1 is equal to 9.15. Q3 is going to be the middle point of the upper half. So let's see here, 1, 2, 3, 4, 5. It's in the middle between these two. So Q3 is equal to 11 plus 11.2 divided by 2. So Q3 is equal to 11.1. Now that I have my Q1, Q2, and Q3, I need to find my boundaries. So my lower outlier boundary is going to be Q1 minus 1.5 times my IQR. Now remember that my IQR is the same thing as Q3 minus Q1. So I'm going to take 9.15 minus 1.5 times 11.1 minus 9.15, I'm sorry. So I need to do this subtraction first and then multiply it by the 1.5. And so I get 9.15 minus 1.5 times 1.95. If I do that multiplication, I get 9.15 minus 2.925. So that gives me 6.225 as my lower boundary. I'm going to do the same thing for my upper boundary. The only difference is instead of subtracting, I'm going to add, and I'm also going to use Q3. So Q3 plus 1.5 times my IQR. So Q3 plus 1.5 times Q3 still minus Q1. So if you notice, 11.1 plus 1.5 times 11.5 minus 9.15. What I'm doing is actually I'm going to be subtracting or adding the exact same number that I subtracted on the first one. So I'm going to be adding a 2.925 here, which will give me a 14.025. So these are my boundaries, 6.225 and 14.025. So if I go back up to my data, 14.025 would be here. There is not a number greater than that. So I don't have to worry about any upper outliers. 6.225 is right here. And so anything less than 6.225 is an outlier. Well, if you notice, I've got an outlier of 5.7. So in this case, 5.7 is an outlier. So we have to be careful with our outliers and be able to identify them. Part of the reason why we want to identify them is just to know that they're there. and be able to look at maybe what's causing them. One thing that we also want to do is be able to graph these things, especially our 5-number summary. On the graph of the 5-number summary, which is called a box plot, we also want to graph our outliers separately. And so a box plot is literally, we create a box using our first, second, and third quartiles. We find our quartiles, and then we draw vertical lines at those quartiles. And then we draw horizontal lines between the first and third quartile to make a box. We also find any outliers and everything. We have to compute our lower and upper outlier boundaries. And what we'll do is, once we compute those boundaries, we will find the numbers of our data values that are just inside there and draw lines from the box to those values. And then on outliers, we'll just put an X. So let's look at what this actually looks like. Here we're going to look at stolen credit cards. So a credit card company has a fraud detection service that determines if a card has any unusual activity. The company maintains a database of daily charges on a customer's credit card, constructed Boxplot for the daily charges. And we have the daily charges here. What we need to do is we need to find our quartiles and look at those. So the numbers are actually already arranged in order from least to greatest, and so I need to find my quartiles. So I need to find my Q2 first, and so going through here, I'm looking for my quartiles, and I find that I am Q2 is going to be here between these two numbers. So I'm going to take 101 plus 111 divided by 2. So Q2 will be 106. Okay, I'm going to delete the markings around here, and I'm going to draw a straight line there to identify Q2. This way I can identify Q1 and Q3. So Q1 is going to be down here, and so I have to take these two and identify. So Q1 is 79 plus 89 divided by 2. So Q1 is going to be 84. And again, I'm going to delete these so it'll help me a little bit later with outliers. Then I'll do the same thing here with the upper half. And I've got 133 plus 143 for my Q3. And divide by 2. So Q3 is going to be 138. And delete my other items. Now that I have my quartiles, I can identify my lower boundary and my upper boundary. So my lower boundary is going to be Q1 minus 1.5 times my IQR. So that's going to be 84 minus 1.5 times 138 minus 84. So that's 84 minus 1.5 times 54. So that's 84 minus 81. So my lower boundary is 3. I'm going to do the same thing with my upper boundary. That's Q3 plus 1.5 times my IQR. So that's 138 plus 1.5 times 138 minus 84. So that's 138 plus 1.5 times 54. So 138 plus 81, which is going to give me 219. So if I look, 3 will be down here, and 219 is here. So that means that I have 2 outliers. Okay? So this is the data that we will need here to construct our box plot. And so I'm going to draw a horizontal line here, and I'm going to label it with 0, 50, 100, 150, 200, and 250. Okay, so Q2 was at 106. So that's going to be approximately right here. So that's my Q2. Q3 was at 138. So we'll draw it about here. And Q1 was at about 84. So about here. And then I'm going to draw the box. So Q1, Q2, and Q3 form a box. So it's really Q1 and Q3 that form our outside area. Q2 forms the inside. Now what we call whiskers are formed by our boundaries and the numbers just inside the boundaries. So notice here's our lower boundary, and the number just inside the lower boundary is 12. So we're going to come here to about 12, put a dot, and we're going to draw a line from that dot to the box. We're going to do the same thing with the number just below our upper boundary, which is 188. So I'm going to come here to about 188 and draw me another what I would call a whisker. So I have box and 2 whiskers. Now this data set has 2 outliers at 220 and 230. So we're going to put those on here individually at about 220 and about 230. And we just make X's for each outlier. So all the outliers are placed on here individually. And then we have our box, which are our quartiles. Our whiskers represent the boundaries. And then since we are talking about the charges for credit cards, we do always want to label any graph that we talk about, and so we're talking about daily charges. Okay, so go ahead and work with the 5 number summaries, outliers, and box plots. And if you have questions, let me know.